So we'll continue to work on this on Monday, and then the quiz for this will be on Wednesday. So those are my tutorial times for next week, and the 2 quizzes you'll have in the following week that we'll test over this unit. So if you're having trouble with this, as you try some over the weekend, you'll have some tutorial time to come in before the quiz. So hopefully you can get it taken care of and not have to worry about re-quizzing. All right, so we left off where we had said this is a gram to gram problem, so it would be 4 steps. And then I had given you a couple of molar masses to make it a little bit easier. KClO3 was 122.5, 55 grams per 1 mole. And I had also given you, what else do we need? KCl. And that was 74.55 grams per, grams per 1 mole. All right. So we're going to start at the beginning, which we have 25 grams of potassium chlorate. And we want to convert to grams of calcium chloride. So the only thing in this equation we're not worried about is the oxygen. So I have grams at the beginning and grams at the end. And now I'm just going to start following my units. If I'm grams of potassium chloride here, I have to be grams down here. So we're in this box right now. Since I see something about grams, that's where my first molar mass is going to have to go for my KClO3. So that would be my 122.55 grams per 1 mole of the same compound. I gave you that, and the number always goes with the gram, and opposite of it is just 1 mole. And then I'm going to keep on taking my units. So moles of KClO3. I'm in this box now, and there's nothing about grams in this box. That doesn't come to this last step. So this is where I have to use my mole to mole ratio because we use that every time. So coefficients. How many moles of KClO3 do I have? 2. And I need to compare that to moles of my unknown, which is KCl. And how many of that do I have? Also happen to have 2. All right, and then we finish out moles of KCl. I'm going to be moles of KCl down here. I do have grams, and although I didn't leave myself enough room, that's where my second molar mass needs to go. So that would be my 74.55 grams, opposite always just 1 mole. All right, I can do a quick check and make sure I canceled out and set up correctly, and I'm left with just grams of KCl. So at this point, you should multiply across and then divide by what's on the bottom. So give that a try if you didn't do it at home to make sure you got the right answer. It would be really frustrating if you did all that work and got it all set up and then just didn't put it in the calculator right. Leah, did you get 15.2 at home? All right. Does anybody have any questions where any of those numbers came in there? Or confused about where any of them came? All right, let's look at number 2 then. When I look at number 2, what is the first thing that I need to do? Balance it, exactly. I feel like we've balanced this equation. It's kind of like aluminum oxide. I feel like we've balanced it a lot of times. My oxygen, I'm going to have to get 6 on each side, which means I'm going to have 4 iron. So that would be my balanced equation. In this one, it says how many moles of iron. So that's one thing that I'm worried about. Must be used to produce 125 grams of iron oxide. So I'm not worried about oxygen in this one either. So my given is in grams and my unknown is in moles. So how many steps is that going to be? 3. All right, so I'm going to kind of get you going, and I'm also going to give you the molar mass on this particular one. So the molar mass is equal to 159.70 grams per mole, and that's for the Fe2O3 iron oxide. All right, see if you can take it from there and finish it out and come up with the right answer. All right, anybody have an answer they want to share? Perfect, 1.57, and my units would be what? Moles, all right, good deal. So I'm just gonna work through that for in case you didn't get it, so we can just see what's going on. All right, so I have grams of iron oxide to start off with. 0.03, and I want to get to moles of iron back here. All right, so if I'm grams of iron oxide, I'm going to bring that unit down here. And if I'm grams, that's when I use a molar mass. So this is when you would use that molar mass I gave you, which was 159.70 grams per 1 mole of iron oxide. And then I continue the process, bring this down here. And I see mole, so that's my mole to mole ratio, so my coefficient. So for iron oxide, how many moles do I have? 2. And for iron, I have how many? 4. All right. And we've done everything right. So now we would just put it in our calculator. And hopefully, if you do that, you'll get the 1.57. Anybody have any questions where I got any of those numbers from? Not too bad. All right, why don't y'all give the next one a try from the beginning to the end? So don't forget to balance it because it's not balanced. I'm not going to give you a molar mass because the molar mass you need is very easy. So see if you can take it through the whole process. All right, anybody got a number to share? 453, perfect. Grams of copper. All right, so let's work through that one just in case anybody's still struggling, and then we can work on some practice. All right, so what mass of copper metal, so that's just my plain old copper, will be produced when I have 4.75 grams of ammonia. So that is my ammonia. And not worried about anything else. So my given is in moles and I'm going to grams. So it's going to be 3 steps. So I'm going to start with what I have, which is my 4.75 moles of ammonia. And I want to convert that to grams of copper. So since my grams is at the very end, that means I won't use a molar mass till the end. So I'm going to follow my units, moles of ammonia. I'm going to have moles of ammonia down here. This conversion box doesn't say anything about grams. That's not till over here. So this is my mole to mole ratio. So for NH3 ammonia, I would have 2 moles. And I'm comparing that to the moles of my unknown, which is copper. And that would be 3. That's just from the coefficients. And then I'm going to continue moles of copper. I have to have moles of copper down here, but now I do have grams in this box. So that's where I need the molar mass. But since it was copper, it was just straight off the periodic table. You didn't have to do a lot of adding. 63.55 grams, and that's always per 1 mole. Then you've kind of done all your work. Just kind of do a quick double check and then multiply across and divide by 2. And we have 3 sig figs, so that was where you should get your 453 grams of copper. All right, anybody have any questions on that one? All right, y'all got about 10 minutes to work on your practice. If you notice on your practice, like on the side, I first of all tell you how many steps and what type of problem it is. And then as you get further in the back, you'll see you have to figure that out also. So we'll continue on stoichiometry on Monday, doing some kind of paired activity, and then we'll just move on from there. So this test for this unit won't be next week. It'll be the week after that. So 2 quizzes next week.